Well, let's get started. The problem of the day, I suppose, is a Reddit question. Somebody asked in our physics. So something flying, floating, hovering inside of a car and asking what happens if the car starts to move. Does the thing that's flying, floating, hovering move with the car, or does it move in the opposite direction relative to the car, meaning it stays still relative to the ground? And I think that was essentially his question. Is that what you remember?
Yeah. I think that was it. It was essentially, or like, it was like, if there's something in the air in a car, maybe we could talk about this. I don't know if it matters if he's talking about like something that is staying afloat of its own, or if it's like in free fall. Is it different? I don't think he really addressed that, but
yeah,
I think just something in the air that's in a car. Why does it move along with the car? Why doesn't it just get like squished against the back? I think kind of.
Right. Yeah. So why don't I maybe put an order to this in just chronologically in my head, meaning this problem, this question, this situation scenario holds kind of some importance to me because it's actually probably the first question I've ever had that was like a physics question before I knew what physics even was. Like I remember thinking about this when I was like a little kid and asking my parents, like driving down the freeway in the back of a minivan and like having a ball in my hand, like why doesn't the ball fly to the back of the car like while we were moving down the freeway, and like having that thought. So I like this question just because of like kind of nostalgic memories of baby me thinking about physics without knowing what physics was.
Yeah, I had a very similar question too. Like, I don't know that I ever asked it, but I definitely thought about like, flies or insects like in the car and like, what's happening to them? Like, do they know they're moving 60 miles an hour right now? I think just like sitting in a car as like a kid, you come up with a lot of interesting physics questions if you don't have anything else to do. Like,
right.
I think everyone wonders at some point, like, why are they getting thrown against their door when their like parents make a sharp left turn or something?
Right. Exactly.
Cars let you do a lot of cool physics, I think.
For sure. Yeah, that and the Feynman book. Surely You're Joking, Mr. Feynman. He talks about being a kid talking to his dad about physics. But again, I don't think he used the word physics, but asking about a ball in a wagon or something like that. Do you remember that story?
I don't. I've only read like a small portion of Surely You're Joking.
Okay. Yeah, something like there's a ball in a wagon and you pull the wagon forward and the ball moves to the back. And his dad pointed out, is like, well, it does move to the back of the wagon, but the ball doesn't move backwards. The wagon moves forwards and hits the back of the wagon when the wagon back comes to meet the ball.
Right.
So like relative to the ground, if you watch the ball, it doesn't move at all.
Yeah. Like if you were standing, or perpendicular to the wagon in line of sight with the ball and the wagon moved, the ball would always stay in front of you.
Right. So I think we can kind of organize things into different categories, meaning that there's stuff that is, like you said, like in free fall, just like, stuff like a ball or, anything you're just kind of throwing in the air. That's moving relative to another object that's moving, like a car. So within a car. And then I think the other category is things that are floating. Like I think we're going to get into like balloons and drones and insects, right? And I think we can split those two things up and talk about them separately and how they're related.
Yeah, but I think there's one little category that might bridge the two that I think we'll get to, and I'll ask it when we get there.
So I think the overarching theme is relative motion in a sense. Not like relativity, but just relative motion, like one object moving with respect to a different object. So the ball in the wagon, relative to the wagon, the ball moves backwards, but relative to the ground, it's not moving. Or maybe it even moves a little bit forward if you pull the wagon forward. And then same thing with the like me thinking about it as a little kid in a car seat throwing a ball like in front of my face. The ball looks like it's just going up and down as though I was sitting, still in my living room, but the car's moving down the freeway. Relative to the car, it looks like it's just going up and down relative to me moving with the car. But relative to somebody outside the car, what kind of path does that ball take?
Yeah, I mean, it's just a parabola, just a standard. Yeah.
It would look like somebody who launched the ball at 65 miles an hour and it went up and then back down a little bit, but it's going 65 miles an hour forward while it's doing that.
Yeah. There's a really great Mythbusters episode, probably one of my favorite ones, kind of about this very thing where they shoot a soccer ball backwards off of a truck going 65 miles an hour.
I used to show a GIF of that in my class when we were talking about that stuff.
Which has the same kind of idea, except it's like a backwards
right
throw.
Yeah, truck moving 60 miles an hour, shoot a soccer ball out of a cannon backwards 60 miles an hour relative to the truck, and then the soccer ball stands still and it just falls to the ground as though you just dropped it.
It's so beautiful. If you haven't looked this up, you definitely should, because it's just like a great example of like you being able to see physics in like action, like what, here's all these equations, here's what we say is going to happen, and then it just happens, and you just like it's amazing.
For sure.
And it was also a great feat of engineering too. I think like Grant Imahara spent like a bunch of hours trying to make that thing launch exactly like 60 miles an hour or whatever the speed it was.
Yeah, I never saw the episode, and when I showed it to my students, I didn't even know it was a Mythbusters clip. I thought it was just an amazing science video, and then found out later that it was from Mythbusters. I was like, of course it is, because they're awesome.
Yeah,
cool. So the ball flying in the air, kind of just it's standard parabola, you're throwing a pass at 65 miles an hour, and you run 65 miles an hour. You can catch your own pass, and that's basically what you're doing when you're inside a car. Throwing a ball up in the air, and you can make the speeds faster and faster. It doesn't matter if you're moving. We're getting into like some kind of fundamentals of physics. Is if you're not accelerating, there's no way to tell that you're moving. As long as you're not accelerating, you can't tell. There's no physical experiment that you could do to test whether you're in a moving reference frame or a stationary reference frame.
Right.
As long as you black out the windows, no vibrations, road noise, stuff like that.
Yeah. Put yourself in a shipping container in space, moving, in a straight line. And yeah, you're not gonna, there's no way for you to know that you are moving or not once you're moving.
Yeah. As long as it's not accelerating. So we'd call these inertial reference frames. An inertial reference frame is just no acceleration. So any test you would do in one inertial reference frame, there's no way to distinguish with an experiment if you're in a different inertial reference frame. All inertial reference frames are the same as far as physics goes. Laws of physics all work identically in those reference frames.
Yeah. And just as a side reminder, acceleration isn't just like changing your speed, but it's also changing the direction of your speed. So you can't be, going 60 miles an hour and going around a racetrack in a circle. Like,
right.
You should be able to tell that.
Yeah, that counts as acceleration.
Right.
Yeah. So what's an example of a test you could do? Say like, am I going on a curved turn versus in a straight line? Like, what would you imagine you could do?
Maybe it depends on how fast you're going, right? But hang a ball from your ceiling or something, and it shouldn't. You'd expect it to be at like 90 degrees, right, with your ceiling, let's say. But then if you're on a curve, and we're not talking about like a banked turn, it's a flat turn.
Yeah, you're just turning.
Yeah, it'll move. Make some angle with relative to the ceiling or something like that.
Right.
Move the opposite direction that you're turning.
Yeah. And it's not like physics is broken. It's just without the information that you were on a turn, there's, how do I want to say this? Like, people understand physics of accelerating reference frames. Like, that's not like, oh my God, we're accelerating, physics is broken, we can't do anything. We have rules for that. It's fine. It's just there's certain. I'm stumbling on it. What am I trying to say? Do you know, Zach?
No, I mean, I think what you said is fine. Is it's just that things don't follow like a Lorentz transformation, right? Isn't that what it's called? I think Galilean transformation. When you're not accelerating, you can't just add velocities linearly, or if I'm going 60 miles an hour and I shoot a soccer ball off the back of my truck going 60 miles an hour, it falls straight down. But if I'm accelerating while I'm doing that, I don't get the same results. Well, right. Yeah.
Well, yeah. And I think what I was trying to say, and stumbling over my words, you can't do a test to distinguish, are you moving at constant speed or are you sitting still? That's the distinction. Like, those two types of reference frames are identical. You can tell if you're accelerating by doing something like Zach said, hang a weight from a string from your ceiling in your car as you go around a turn. Then you could immediately tell, oh, I'm in an accelerating reference frame. The physics isn't behaving the same way. But if you were in a blacked out car, no view of the outside motion at all, you wouldn't be able to tell if you have cruise control on or if you're sitting parked. You hang the weight from the ceiling and it behaves the same way in both situations.
Yeah, and you actually might have like experienced this slightly as a kid. I think I did. If you just pass out in the back of your car and you're asleep, you wake up, you don't immediately know whether you're moving or you've stopped at a restaurant or something. It's unless you start coming more alive, you feel it, or you look out the window. But until you do one of those two things, you can't really tell either way.
It always hits me in a plane when I'm thinking about, we're going 600 miles an hour right now. It's kind of incredible. I'm just kind of walking down the aisle. It feels like I'm in a hallway. Like, there's no distinction besides the noise of the plane. As long as there's no turbulence, it feels the same.
Yeah. Cool. Yeah. So, if we go to our kind of Reddit question, I guess, if you are throwing a ball or doing something when you're in a moving car, it's the same thing as if you're standing still, is essentially kind of what we're saying, right?
Right.
But then, I mean, is there anything else that we want to say on that sort of topic?
No, I don't think so. I think we can move into some more interesting situations.
Yeah, we've all kind of had that experience. We all can imagine it, I feel like, at least. But yeah, so then the next thing is if you have like something, the difference between these two situations is you're throwing the ball while you're in the car, and now you have a drone or a fly or something in the car that's floating of its own accord. Mm-hmm. Now what happens? Is it going to be like that ball on the wagon that you were discussing? Like, if you have a fly just sitting in there and the car starts moving, does it just like move to the back, or... Okay, yeah. Maybe you have a better way of phrasing this.
I was going to say we should be careful not to say that the car starts to move. Like, if you're driving with cruise control on, straight line down the freeway, and you have a drone sitting in your lap off, and then while you're driving at that speed, turn on the drone and have it fly, what's it going to do? It's just going to, do what it would do if you're sitting in your living room and did the same exact thing. It's just going to hover in place in the car as the car moves down the freeway.
Right.
Right? I think we all agree that that's going to happen.
Right. Yeah. So, I think the interesting thing to ask about, and I think that's what the question was getting at, I think, is accelerating. Is that
okay? Is
that right?
Yeah.
Or I don't know. What do you think?
I don't remember, but we should talk about that. Yeah. So it's hovering in the middle of your car, and then you start to drive. What's going to happen to the drone? That's the question.
Yeah, I think so.
Yeah, I mean, that seems more interesting. Like, it's not an obvious answer.
Right, yeah, because if you're already driving, like you said, we kind of already know, it's the same thing as standing still. But yeah, maybe we can talk about the ball if you are accelerating, like what happens there. Mm-hmm. Before we go into like a floating thing.
Sure. Yeah. So if you're driving on the freeway at 50 miles an hour and then slam on the gas while you're throwing a ball in the air, the ball's going to fly back in your face or to the back of the car, right?
Yeah.
The car is going to accelerate forward. The ball is no longer going to be moving it's going to continue relative to the ground in its nice little parabola. But the car itself is now accelerating, and it's going to, shift the ball relative to the car to the back.
Yeah, right. Like the thing I was thinking about, this was like kind of the interesting, maybe like in betweener that I was thinking is like if you dropped a ball, like the second you drop a ball, you just gas it and you just start going.
Mm-hmm.
You're just gonna, if you're outside of the car, you're just gonna see the ball move in a straight line, fall straight down. But inside the car, it's taking this like wicked turn towards the back of the car. So, but even then, okay, I think now we're like, okay, we understand this. Like, I think this is intuitive for everyone.
Right. I agree.
So I think, yeah, now that we're kind of there, the next step is these floating things,
right?
Flies, drones, balloons.
Can we talk about the balloon next? Because I know the answer to the balloon, and I think it might be helpful for the answer for the drone. Because I saw the videos. Somebody in the Reddit comments posted a video of a drone in a car, and I have some issues with the video we can talk about, but I think it'll inform, the balloon conversation will inform the drone conversation.
Yeah, the balloon one is interesting, and if you've taken a mechanics course or like I think that's probably where you'd see it. You've probably talked about this or like seen it. The other like demo that you see this in a lot of is the two inverted jars of water that have what do you call them? Bobbers in them, and they spin in a circle.
Yeah. Or
the candle flame, same thing. Candles spinning in a circle.
Oh, I don't think I've seen the candle one.
Yeah. If you seal, I don't know if it's completely sealed because then the air, the candle will just burn through all the air. But yeah, you can do, if you put candles in an enclosed thing, at least relatively enclosed thing, and then you spin it, what'll happen to the flame essentially is the question. And I think we can answer that maybe after the balloon. I think the balloon gives you a better.
Yeah. So the balloon, imagine, you talked about hanging a weight from your ceiling and you accelerate forward, the weight is going to move to the back of the car. The balloon, however, if you did this and tied a balloon to the floor of your car and accelerated forward, the balloon moves forward, points in the same direction you're accelerating. And the reason is to think about why a balloon floats at all is there's a slight pressure and density difference between the bottom of the balloon and the top of the balloon. There's a little bit more pressure at the bottom of the balloon that pushes upward on it compared to the top of the balloon, which is pushing down. So because of that, the balloon floats up, a helium balloon that floats. In the car now, if you accelerate forward, there's all of a sudden a higher density of air at the back of the car. Just same reason why the weight on the string moves to the back of the car, the air moves to the back of the car. And then what's going to move forward? It's in relation to all the air moving back. That air moving back pushes on the balloon forward. So you end up with the balloon moving forward. Yeah.
So, all the air gets compressed in the back of the car, creating a kind of a denser a pocket of air, if you will. And so that's gonna push the balloon forward. It's a cool little force indicator, actually. It tells you in which direction force is being applied.
Yeah. So you end up with the balloon floating forward when you accelerate your car forward. And it kind of looks weird, but it does happen.
Yeah. And the opposite if you slam on the brakes.
Yep. Slam on the brake, all the air moves to the front of the car and the balloon moves to the back. So it points in the direction that you are accelerating. Okay. So air movement leads to the balloon moving in the accelerating car. How about the drone? Is the drone, it's not the same, it's not buoyant, right? It's a little more complicated. Like what keeps the drone afloat? It's the blades cutting through the air pushing the air downwards because of the motion of the blades. So it'll hover because of the blades moving. But if all of a sudden you made the air more dense and the blades moved at a constant speed without accelerating, just I don't know, increase the pressure in the car somehow, just uniformly, not one direction or the other. If the air is denser and the blades cutting through that more dense fluid, does it get more lift? Like, would it rise up if all of a sudden the density increased?
I think so. I want to say yes. Just because, so, it's a change of momentum equation, right? Where
right.
You're knocking some air particles downwards, so therefore you're going to get a force upwards. Mm-hmm. So I'm not 100%. I think you might have to assume that the blades are moving at a constant angular velocity, despite like the density. So you put it in syrup, they're still moving at the same velocity.
Yeah. There's some limit to this, but just, slight increase in air pressure.
Yeah. Now you're knocking more air particles downwards. Mm-hmm. Therefore, the momentum change is greater. Therefore, I think you should go up if you keep the velocity constant. Yeah.
So I think that assumption is important, or at least that like theoretical understanding of how drones work. And it's totally possible that that's completely wrong and that's not true at all. But I think we need to make some sort of assumption like that to think about what should happen with the drone.
Right. Well, I think that's got to be the way that, blades work in general, whether it be on a fan or a helicopter or a plane or a drone. Mm-hmm. Right. Is you have to generate lift by moving air. And so it's just, it's got to be a change of momentum thing.
Right. So if higher density leads to more lift, then a drone, let me talk you through what I'm thinking, and then you can correct me if I'm wrong somewhere. If the drone's horizontal inside the car accelerates forward, a bunch of air moves to the back. There's a higher density. I'm imagining like it's a quadcopter with the two blades forward and two blades back. Does that picture make sense?
Yep.
The two blades towards the back are in the higher density air than the two blades in the front. So I think the back of the drone would lift up, and then I think the drone would move forward, kind of up and forward.
Yeah. It's gonna kind of tilt a little bit, which will now give it some forward momentum. Yeah, that's exactly kind of what I was thinking. It is, I think the balloon really helps. It tells us what's going on with the air in the car. And then once we have that understanding, we just kind of have to make this assumption of how drone flight works.
Mm-hmm. And it's kind of interesting because if you think about what happens over a longer period of time, it starts breaking down because the rear blades are going to experience more lift than the front blades. The thing's going to tilt forward. And at some point, it's not going to have, it's going to end up, if the drone was completely vertical, it would just fall, right? Because it would have zero lift against gravity. Gravity would pull it down. It would be moving forward and then falling at the same time.
Right.
So is there an equilibrium where it stops tilting forward because it starts to fall? Or, I mean, if it's vertical, the front, quote unquote, and back blades, what used to be the front and the back blades, now are at the same pressure. Well, slightly different for the same reason the balloon floats, but
right, yeah. We could maybe make a fake system of equal pressure.
Mm-hmm. So, is there a moment where that drone stops tilting forward?
Yeah, I mean, so it's not just going to. The change in angle must be related to the gradient, right, of the air in the car. And yeah, so I mean, I think it's if the blades are moving at a constant angular velocity, then on average, I think they're hitting the same amount of air, pushing the same amount of air, or the amount of air that they're pushing downwards is only proportional to the density. So the force will only vary with the density of the air. So I think yeah, it's just whatever the density is will cause it to have a little more force downwards or upwards, which will provide some torque and raise it. But the net force downward is still equal to gravity. The net force upward, because it's pushing air down. Net force upward is equal to gravity. It's just now there's some amount of it also going in the horizontal direction, and that's gonna push it forward. I don't think it ever is gonna fall. I think it's just.
I see. Yeah, the picture I'm having in my head, and I think what I said a little while ago might have been incorrect, in that we can't ignore the vertical gradient. Like there's the horizontal one from the acceleration, but then there's still the vertical gradient of pressure difference in the car, just from gravity pulling. At the bottom of the car, there's more air than at the top.
Right.
So I'm picturing, like, maybe you've seen or can imagine like bus windows that have rainwater trapped between two panes of glass, and the bus accelerates, and you see the like kind of like diagonal line of water. Have you seen that?
Yeah.
Yeah. So I'm picturing that. Obviously not exactly that line of a divide, but like that's kind of the picture of like I don't know what the word is. Pressure. What's it called?
Equibaric? I don't know.
I know isobaric is like a process, but that's not really what I'm trying to say. Yeah. Equibaric, let's say. Anyway, lines of equal pressure are kind of like diagonals, right? And so I think the drone would rotate until it lines up with one of those lines of equal pressure and then start accelerating. Or would it stay in place? Maybe it would stay in place. Maybe it wouldn't move forward at all. No. It must. The free body diagram, you get some forward component.
Yeah.
But maybe it would start dropping also, because the force downward's the same. I guess I also don't know how a drone works, because like, do you just set it to be level? You just say like, hey, stay at the same level, or like, how does it know?
Yeah, I think the way that it works is through like, I think, a PID controller.
But you're setting the how much it goes up and down, like the because obviously you can have a drone fly really high in the air, so you can say like, oh, change your altitude. Is that all through you just touch, like your feel on the trigger, the controller? Like,
well, it depends on which model you get. If you get the really expensive one, what it does essentially is it's got an accelerometer on it, or multiple accelerometers, and if you're telling it to stay still, it's going to measure, look for no change in acceleration, and if it starts to feel one, it's going to change the blade speed to counteract that. So if it's accelerating downwards, it's going to speed up the blade to push it up a little bit further, or if it's vice versa. But I think that getting into that's like a little too complicated for let's just. I think what I just said earlier might be wrong, actually. Welcome to physics. I think we both have just said, I think we were wrong 5 minutes ago.
Yeah.
So I'm imagining now, if maybe not. Okay, I was thinking, if the okay, all right. I think I might have it. Hear me out. Okay, when the car hasn't started moving yet, there's on the front half there's some force upward on the front half and some other force upward on the back half, and the sum of those two forces is equal to the weight of the drone, because it's not going up or down.
Right.
Then you start accelerating, you create this pressure gradient. The front half goes down in pressure, therefore it has less force, so there's less on the front side. But the other side gains pressure, so there's the force upward is bigger over there. But I think the sum of those two forces is still net the weight of the drone.
Is it exactly balancing, like still opposite direction? Like the upward amounts, well, the total force, well, I don't know. Two ways to ask it. Is the upward force of the propeller blades equal to the downward force of gravity? Because I'm imagining
that's what I'm saying, but
okay.
I don't know if that's right. Actually, maybe I'm wrong about being wrong. I have no idea.
My thinking is it's not right. So again, I think we have to go back to our assumptions, not the same assumptions we had before, but now we need new assumptions, different assumptions, additional assumptions. One being that the blades stay at constant speed.
Right.
So if the blades are at constant speed, the same speed that required the drone to hover in place, if the blades don't change their speed, I think the drone would tilt forward.
Yes.
Which would apply the same force that used to be straight up to hold the drone in place is now like forward and up, like kind of like diagonally towards the front of the car and upward.
Well, but so we can have the possibility that the net force upward is still the same, but that there's also more force and it's going sideways. Like there could be, we could change the torque on it and have it rotate, but have the net force up still be constant.
What are the additional force? Like if it was 10 newtons of force upward, say the thing weighed 10 newtons, then all of a sudden it rotated forward. The total force is 10 up and say 1 to the left or forward towards the front of the car. So 10 up, 1 forward, you now have a magnitude of, whatever that is, 100 and square root of 101, whatever that is. You have more force. So where did that other force come from if the blades stayed the same speed? Yeah.
So to get really into it, I think what it is that the blades are staying the same speed, even though there's a denser material there, the battery is applying more energy to that blade now to keep it going at that speed. And so that's where the energy is coming from. And then the more denser air is creating more of a force.
Okay. I think I get what's happening. So when the car is not accelerating, the lines of equal pressure are horizontal.
Okay.
The drone is fixed at one of those horizontal lines, like it's just hovering.
Okay.
Now, when we start accelerating, those lines of equal pressure turn into diagonals.
Right. With you.
And the drone lines up with one of those diagonal lines of equal pressure. And I think what you're saying is that the line of equal pressure that the drone sits on now is a higher pressure than the line of equal pressure, like whatever the pressure is, 1.1 atmosphere is the diagonal line of equal pressure, whereas 1 atmosphere worth of pressure was when it was hovering horizontally.
Well, maybe. I'm trying to think of it. I was also trying to come up with a more extreme case. So let me stick with what you're saying right now before I try and change it. I think what you're saying is good. I like your description of it with the drone trying to stay at like a equibaric line. I'm going to Google that real quick.
I am too. Lines of equal pressure. Isobars, but that's like, I think of that as like a thermal process, but I guess it's an isobar.
Yeah, I guess that makes sense. Yeah, it's usually like referenced as a process, but
it was a New York Times crossword puzzle clue.
Okay, so some isobar, I guess, line of equal pressure. So I kind of like that thought. Yeah, that it's going to move until it's at an equal one. It's going. So I was trying to think of like an extreme case that I don't know if it made sense. I was imagining if there was a way, you could make it such that essentially the back half had, I don't know, let's just say 1 atmosphere of pressure on it, and the front half had no atmospheres of pressure. What would happen in that case? Because I think the case that you are describing with your isobar lines and then the diagonal isobar lines, I think that would say that there is no additional force, right? Unless it moved to a higher isobar, I guess. But I don't know why that would happen.
Yeah, I don't know either. But that's the only way I could think of there being an upward force equal to the weight and then also an additional forward force if the blades are moving at the same speed. I'm equating higher pressure of air to higher force of lift, which I think is valid.
Yeah, I agree. I think that's true.
So if we need a magnitude of the force to be bigger when the drone's tilted, bigger than when the drone was horizontal, I think the only way to do that is to get more dense air.
Right. I guess what I'm saying is I don't know if it. So if it gets, we're thinking if it gets in more dense air, it's going to not fall. Right. We're saying the magnitude of the force has increased. Because like you said, it was 10 before it rotated, and then it rotated some, and now it's 10 up still, but 1 to the side. Now it's whatever that is bigger. I don't know that would happen. I think it might just still be 10, like you were saying.
Yeah, I don't know either. So let's say it's perfect and it's just ooh. So this is interesting. Let's say it did have an upward force of 10 still, but a forward force of 1. It would accelerate forward, but then by moving forward, it hits a line of less pressure, which decreases the lift. The upward force. It decreases the whole force, I think.
Yeah, the magnitude, I think, is how we're kind of viewing it.
Right. So I think it all it's going to start dropping no matter what. If it starts off with a balanced upward force, it's going to move because of the forward amount of force. It's going to move to a line that doesn't have that much, and then it's going to drop until it hits the perfect, isobar of the right amount of pressure again.
Well, I think
it's going to move along an isobar, I think is what's going to happen.
Right. I think what would happen is that it would let's say it's at an isobar that's equal to, keeping it at 10 newtons when it's flat. It rotates. I think it's just going to slide down that isobar.
I think that's exactly what's going to happen. Yep.
Another way to visualize this maybe, I'm wondering if this will help our intuition at all. What if we had like a little pool filled with water and a boat in it, and did the same thing inside of a car, in a van?
Right. I think it would slide down, like as you accelerate, the water would slosh to the back of its tank or tub or whatever, making like kind of a ramp. And I think the boat would slide to the bottom of that ramp. Actually, I don't know. I think that's what would happen.
I think so. Part of me wants to say the exact opposite. It would go up the ramp.
That's why I said I think, because then I was like, wait, it's floating. Does it go up? But I don't think. No. Oh, this is a problem I've done before, where you have like a floating styrofoam in a tub of water that you rotate like on a turntable, so it makes the little concave shape of water, the parabola, which is a fun proof to prove it's a parabola. The cross section of water. But if you have a little thing that floats, where does it stay stationary, or does it stay stationary? I think I've done this problem.
That actually sounds like an interesting problem, because it's like,
yeah,
like part of you wants to say, well, it's going to go to the bottom of a parabola because that's what everything does, but then it's floating, so is it going to go up to the edge? That's an interesting problem.
Well, I don't think it's a floating issue. I think it's like a centripetal balanced force issue. Like you could solve it with a marble in a bowl that's spinning. Like what height does the marble stay at if it's spinning around at a certain rotational speed? Let's save that for another day, because that involves a little math interlude, which we're trying to avoid.
Right. What happens? Essentially, we want to. Well, the question will be at a future podcast: what happens to a boat in a whirlpool?
Yeah.
All right, but I guess maybe the water isn't the best example, because a boat is never going to leave the surface of the water.
Mm-hmm.
So maybe it's just a red herring of an example to begin with. Yeah.
And I think something we can say, just to tidy up our thoughts on that it's not going to go up the water unless you accelerate very quickly. The buoyant force is perpendicular to the surface of the water. We agree on that?
Yeah, yes.
Okay, so it's not the buoyant force that's going to push it up the water ramp.
Right, yeah, it would be like
inertial acceleration, like the mass of the boat, like the water's moving underneath it. We'll save that. But back to the drone, I think we're right in that. I guess it's kind of what you were saying. Yeah, I guess it's does the boat go up or down the ramp of water as you accelerate? Does the drone move up or down the isobar line, diagonal isobar, as you accelerate?
Right. Oh, I think it's got to be. I mean, if we're okay, we can make an assumption that the force perpendicular to the drone, let's say that force is always constant.
Mm-hmm.
I have, I think that's kind of what we're theorizing. I have no idea if that's true. But if that is true, it has to move down and to the left, because when you rotate it, some amount of the force is going to move it to the forward direction, and that means the rest of that force can't keep it up anymore. So it has to go forward and down.
But how about this? You accelerate it. So imagine it. Remove the boat, remove the drone. I'm now thinking about a car, like no car, even just a block on an inclined plane, frictionless. Everything's ideal, frictionless.
Mm-hmm.
The block's going to slide down the inclined plane, right? Like it's going to go to the bottom. Now, put the block in the middle of the inclined plane and accelerate the inclined plane towards the block.
Right.
Like push, I'm imagining a triangle of a plane with the part touching the ground to the left, and then it goes up and to the right.
Right, okay.
So push the inclined plane to the left with the block on the inclined plane. Like accelerate it to the left. I think if you accelerate enough, that block's going to move up the inclined plane.
That's what my intuition wants to say too, and I'm trying to reason it.
I think there's an acceleration range where if you're not accelerating enough, it slides to the bottom, just like if it was still, but maybe more slowly. If you're not accelerating enough, if you accelerate too much, it's going to fly up to the top of the inclined plane. And there's like a Goldilocks perfect acceleration that's going to hold that block exactly in place on a frictionless ramp.
Right. Because, well, if you accelerate it, if you accelerate the block underneath, you are creating a normal force greater than the weight of the block, right?
Right.
So in this situation, you have a changing normal force, but in the assumption of the drone, if the normal force is constant, then it's different. So maybe what if we want to say that this inclined plane is analogous to the drone, then I think our assumption that the normal force is constant on the drone is wrong.
Yes. Okay. I agree with that. And I think the way to think of it is if you just accelerate this car, just floor it, and it's just crazy fast acceleration, the drone's going to end up rotating, but it's going to be, you're going to find it in a line of higher pressure, which is going to increase the force the blades push with. So it's going to be moved back into that perfect, whatever isobar that it needs to stay wherever it was before.
Sorry. Okay. Say that one more time. I'm trying to.
So instead of the inclined plane, you accelerate the inclined plane, the block's getting pushed into the inclined plane. Like you're saying, there's a normal force, which increases with your amount of acceleration of the inclined plane under the block. Similarly, if you accelerate the car forward, the air gets denser as you accelerate the car really quickly. I think the drone would kind of like not be able to react instantly, but kind of get pushed into a higher pressure area than where it was before.
Right. Okay.
And that would lead to a bigger force, just like the higher normal force would.
Okay.
And I think it would then start to go up. And what I said earlier, I don't know if this is true. I don't know if it would go back to the same pressure that it was. Like we were kind of talking about how there's like this perfect pressure that keeps the thing balanced. Like whatever horizontal pressure it was at before. I don't know that it would go back to that pressure exactly. I think this is more complicated than that.
No, I think you're right. I think this would be a really interesting.
It's like a squishy ramp. It's like more complicated because you made a squishy inclined plane that you're accelerating.
Yeah, well, yeah, and one with the angle can vary. I guess that doesn't really matter.
Yeah, but you're right though. The angle does vary with the acceleration. This is tough. This is getting really tough.
But I think what we're getting at, and I think this would be like really interesting to try, and this is not what's in that video, is you could create a situation where you accelerate the car and the drone moves forward. Okay, I think it's always going to move forward. It's going to move towards the front of the car, assuming you're accelerating that way. It's always going to move towards the direction of acceleration. But if depending on what that acceleration is, you could potentially have it slide down, go towards the bottom of the car. You could have it stay exactly in one place, or you could have it go towards the top of the car, just like the inclined plane. I think you could create all those situations, and that'd be interesting to see. If I don't know if you could.
Yeah, it tilts towards the front of the car no matter what.
Yeah.
But it either slides to the bottom along a line, or it slides to the top along a line.
Oh, right. Which would be
backwards.
Man, I didn't even think about that. Okay, yeah. Backwards. Yeah, you're right. So it can move backwards too. It's not always in the direction of the force.
And okay, so let's get to the video that the person posted in the comments. The video is some guy inside of a minivan with a drone, and he took out all the seats except the driver and front passenger seat, and he's just kind of in the back of the van, which when he started that video, I was like, dude, you're bananas for thinking you're not going to get cut. Like, to be in that small of a space with a drone flying in a moving car without any like goggles or any protection was crazy to me. And then sure enough, he cut himself like halfway through the video.
I didn't see that part. Wow.
So there's that. First of all, don't get in a car with a drone. That's really stupid. But I think what we're kind of working with here is, we're not really assuming this explicitly, but in my head, to think about it nicely, is that it's constant acceleration. And the video, it's not super clear. Like the drone is moving all over the place during that video. He says, yeah, it moves with the car as the car moves forward. It's true, it did. But it's really like, there's only 1 second or maybe 2 seconds worth of drone flight to even like analyze. And then the driver, who I think was his wife, she's just kind of stepping on the gas really slowly. It's not constant acceleration. It's kind of jerking around. Like, even a small change in acceleration, I think would affect the way the drone flies quite a bit. And it seemed like it. The drone was all over the place.
Yeah, and it was a nice drone too. I think it was like a Maverick or something, which should have all the fancy, being able to keep itself set. Like
sensors and adjusts. Like the constant blade speed is definitely not happening.
Yeah, and I don't know if he set it to that or not. He might have just been trying to fly. Yeah, it'd be a really hard experiment to do.
Mm-hmm. Yeah, in this idealized situation that we're talking about.
Yeah.
Yeah, I mean, she does drive the car and accelerate it, and the drone stays in the car. Actually, See, he didn't even really go into like, oh, we're accelerating now, and now we're moving at constant speed. Like at some point, definitely the car was moving and it seemed like constant speed and the drone was staying in place. And I think that we would all say, yes, that makes sense. But it's kind of the start and the stop, and she took a turn and the drone went to the side of the car, like that kind of stuff. All of that was kind of not done scientifically.
Yeah, not a great experiment, maybe.
No, but he said like, "Oh, conclusive." I'm like, I don't. It's not very conclusive to me.
I think one of the little good bits that they do is like, oh, well, let me just phrase it to you. Hey, Derek, we've been talking about a sealed car. What happens if you open the windows?
Right.
Like,
and actually, now that you say that, I think that was part of the original question. The original thing was like, if we open the windows, what happens? So. Yeah, so he did that, and he had the drone flying in the minivan with the doors open and the back hatch open, and then van sitting still, drone flying. His wife, I think, started driving the van forward, and initially it looked like the drone was going with the van, like a little bit. Like, and you can kind of imagine that, like it's a pretty big surface that's kind of like sucking air as it moves forward. But eventually, it seemed like it got towards the back of the van enough that the garage air, the van was starting in the garage. Like the van air mixed with the garage air to a point where the drone just like kind of stayed in place and the van pulled away.
Yeah, and I thought that was a pretty good showing of at least that portion of it. You know, that the air trapped inside the van is really affecting the physics of like this insect or a drone or whatever.
Right. Whatever's flying. Car. Right. Exactly.
Whether, however it's doing that maybe is up to debate, but like it's definitely involved in the situation.
Right. And that kind of harkened back to the famous internet debate of 2012. I don't know if it's 2012, but it's somewhere around there of will the plane take off? Do you remember all of that going around?
Was that another Mythbusters one? I know Mythbusters did.
They did it.
Conveyor belt.
Yeah, they did the conveyor. Yeah. So will the plane take off? Basically put a plane on a treadmill and run the plane or run the treadmill backwards as the plane's trying to take off forwards at the same speed. Would the plane take off? And then, yeah, Mythbusters built a treadmill that's like the length of a runway. Or I think it was just a big tarp or sheet. And it was the length of a runway. And they had a truck pull the sheet against a plane trying to take off on the runway. That was their test.
Right. And I honestly, I feel like the answer should be no every time I see that. But if I remember correctly, it does.
It does. Off. Yeah, it's all about relative to the air, the plane's motion relative to the air. The wheels can do whatever they want. They can spin freely. They can not spin, doesn't really matter what the wheels are doing. It's all about the propeller with respect to the air. So as long as the propeller's pushing the body of the plane through the air, the tires on the bottom, it doesn't matter. They're just going to spin twice as fast as the plane's moving.
Maybe I'm missing what's happening on because these are prop planes, right?
Yeah, propeller planes. Yeah. Although I don't know if a jet would really matter, but
well, with a jet
or like a rocket,
a jet I could imagine, a rocket I can imagine. Prop planes is where it gets me because maybe I don't know how prop planes work. Does the propeller push air across the wings?
No. I mean, you can imagine a plane with the propeller on the front, like the nose of the plane. I mean, I guess it kind of pushes it over the wings, but that's definitely not like the main way to get lift.
Right. So what I'm imagining is a plane not moving at all, and then just with the propellers going, and then it just takes off. No. Because
say that the liftoff speed of the plane, say it's 50 miles an hour, and maybe it's 100. I couldn't even tell you what the liftoff speed of a plane is, but say it's 50. You have a plane moving 50 miles an hour with respect to what? Not the ground, but the air. Because that's what the wings need, is the air moving across the wings. Right. And it's not due to the plane or the propeller. Like, gliders don't have propellers and you just tow them up to speed and then they get in the air. Right.
Yeah.
So it's all about how fast the air is moving across the wings. And so the plane moving forward at 50 miles an hour with respect to the air doesn't matter what the ground's doing. Like you could turn a big fan on and blow air across the plane at 50 miles an hour, the plane's going to get lift and take off. And it's going to be moving at 50 miles an hour with respect to the air. But maybe the ground is just sitting still right below it. It's not doing anything.
But my thought is the plane with the conveyor belt, the plane's not moving. Like the plane's trying to move forward at 50 miles an hour, let's say.
Right.
Relative to the ground.
And you pull the treadmill.
And you put the treadmill. What?
I don't know if it's moving relative to the ground at 50 miles an hour. It's trying to move 50 miles an hour with respect to the air. So you just turn on the propeller, start moving 1 mile an hour. Your treadmill's moving 1 mile an hour backwards. And here's the thing. The only difference is the wheels are now spinning as though the plane's moving 2 miles an hour. But the plane is still moving 1 mile an hour forward.
Okay, so if I'm standing on the ground watching this plane,
yes,
it's moving with respect to me.
Yes.
Okay, that I totally get.
Okay.
But for some reason, I thought that the question was that you'd be able to essentially cancel the motion of the plane relative to the ground
with the treadmill.
Yeah, and then if it's in there's no wind blowing, I wouldn't see how it could take off.
Yeah, no, not with a treadmill. The only thing you could do is like turn on a fan that's like opposing the propellers and just like stop the propeller air from moving. But that's I don't know.
Okay, well, that was an offshoot.
Yeah. But it made me think of that, like the drone flying within the van and then the van pulling away. It's the same, at least in my head, it's kind of the same like fallacy of it's all with respect to the air. That's the only thing that matters for flying things with propellers and wings and stuff like that.
Yeah, exactly.
So just look at the air. Whatever the air is doing, that's what's going to dictate what happens to the flying thing. And with the van pulling away, I think the air is just going to stand still.
Yeah, right, exactly. I mean, it starts moving a little bit, when you kind of like if you, I'm trying to think of a good example. I feel like there's times where you have like things stuck to a table.
Yeah.
And you try and pull it up really quick and it gets kind of stuck for a second and then so there's some initial pressure differential, which is what you were saying, but then it equilibrates and now it's just in static air, so it's not going to move.
Right.
Okay, sorry, I'm just going to ask this question that we kind of talked about. Is it the same thing with a fly?
Same thing as the drone?
Yeah.
I think so.
Cool, because
I don't see what would... Oh. Well, there's no tilting. There's no like front and back propellers.
Right, yeah, that's kind of what I kind of like am reducing a fly down to a line in my head. Like it doesn't have the front and back symmetry that it only has like a side to side symmetry in my head. But I guess it doesn't matter. I think.
Yeah, I don't think it matters. I mean, it's like treading water if it's floating in the same place, right? And if you like tilted the surface of the water and kept treading, you kind of would just still be at the surface of the water.
Right. Yeah.
That's how I'm picturing it.
Yeah, I really wish this guy's question was still here so we could answer it. Zerkaria, if you listen to us, please just undelete your question, send it in. Yeah, so that's pretty. And there's a lot of things to like think about when it comes to this sort of stuff. I mean, like you can try this at home with the balloon, tie a balloon to your car.
Yeah, definitely. And you can look at a video someone posted from Smarter Every Day that he did this with his car and his kids. And he had a good demo with a jar full of water and had like a little air bubble. And then he showed accelerating the jar, showed where the bubble moved, which matched where the balloon went. Yeah, and it's kind of a cool device you can do. I guess you could do it with an air bubble, or you can take a fishing bobber and put it in a jar and then turn the jar upside down and the bobber will float to the top. Mm-hmm. But it becomes a force indicator where it tells you the direction that the force is pointing if you move it. It's like a cool little kid's toy you can make. Yep. Yeah. Well, I think we did this question justice. I think we tackled it and went farther than I thought we would in terms of the analysis.
Yeah. I didn't think it was going to go that deep either. But I mean, if you know more, I mean, I think drones aren't necessarily the biggest thing to talk about, but if you know kind of like how, propellers for like helicopters and that sort of thing like work, and we were way off base, let us know. I'd like to know a little more about it.
Yeah.
But yeah, I really like the idea of I mean, it's a liquid. It's going to move just like the air is going to move just like water does.
It's a fluid.
Yeah. Sorry. That's what I meant. It's a fluid. Air is a gas.
Yeah.
But yeah, so it's going to move, like water does. And so it's a good picture of those isobars, like you were saying. Mm-hmm. I feel like that's kind of where it all comes into.
I think so too. Well, cool. Yeah, let us know if we don't know what we're talking about. I'm sure we'll hear from drone experts, designers, manufacturers.
Yeah. Well, I was going to say if anyone else could do that experiment.
Oh yeah.
But I feel like you can't really do it with a drone.
What would you do it with?
I don't. If you can find a way to make your drone if you can set your drone propellers to move at a constant velocity, whether it goes up or down, then do it.
Yeah.
I don't know if you can do that, though.
I don't know either. And if you do a helicopter instead of a drone, I didn't get into this, but Smarter Every Day has another video on helicopters, like when they tilt forward, like they move forward on their joystick to turn right, like the way the angular momentum and like torque happens. So if you had a helicopter and it started to tilt forward, it would drift right and kind of, I think, ruin the whole thing.
Oh, interesting. I didn't.
Yeah, I don't know all about that. I don't know a lot about that, but
is that a helicopter with the back a back prop, like a sideways propeller?
Yeah.
Versus like a two horizontal propeller.
Oh yeah, I don't know how that works. And they might move in opposite directions to like counteract that. I'm not sure.
Though, yeah, the ones that have two propellers on top, they spin in opposite directions.
Okay, that makes sense. And then I would assume a drone has like two going one way, two going the other.
Yeah, I would. Well, yeah, I don't know. I would think so, but I'm not.
Yeah, I'm not positive.
I'm not sure. I mean, it might be. I feel like it would be kind of nice to have some angular momentum to it to stabilize it, but then I guess you're gonna like put some torque on it somehow, and if you start to change the angular momentum. Yeah.
I don't know. But whatever you do, wear protection, use goggles.
Yeah.
Don't be like the guy in the video.
Lesson of the
don't climb in a box with a drone and start driving around.
All right. Well, that was a good one. If you want, you can tweet me at @AskBullyZak. I need to change that.
Yep. I'm like tortilla. I'll see you next time.